Right now, off the coast of California, the ocean is doing something it has never done before, something no computer model built before this year was designed to fully account for. Not warmer than usual, not just another El Niño. Two separate massive weather systems are colliding in the same stretch of water at the same time, and scientists who have studied this pattern for decades are watching numbers come in that don't match any model they've built. A marine heat wave that started over a year ago, completely on its own, is now being slammed by one of the strongest El Niños ever measured. A heat wave that had no business still being here this long, and an El Niño that arrived faster and stronger than almost anyone forecast just months ago. And the two aren't just adding together, they're stacking. If that sounds like a technicality, it isn't. The last time something like this happened, in 2014 through 2016, roughly 100,000 seabirds died. Sea lion pups starved on beaches because their mothers couldn't find fish. Whole fisheries collapsed, and every sign right now says this year could be worse. This is the story of the Super El Niño of 2026, why it caught scientists off guard, and exactly what it means for California in the months ahead. Let's start with what El Niño actually is, because the term gets thrown around a lot without much explanation. El Niño is the warm phase of a natural cycle called the El Niño Southern Oscillation, or ENSO, which shifts back and forth every 2 to 7 years between warm conditions, called El Niño, cool conditions, called La Niña, and a neutral phase in between. During El Niño, the trade winds that normally push warm surface water toward Asia and the western Pacific weaken, and that warm water sloshes back east instead, piling up along the coast of South America and spreading north toward California. That shift doesn't just change ocean temperature, it reshapes rainfall, storm tracks, and wind patterns across the entire globe. Most El Niños are mild. A handful of times per century, one becomes something else entirely, a super El Niño, officially defined as sea surface temperatures in the central Pacific rising 2 degrees Celsius or more above the long-term average. Only a few events have ever crossed that threshold with confidence. 1982 to 1983, 1997 to 1998, and 2015 to 2016. As of the most recent update from the National Oceanic and Atmospheric Administration's Climate Prediction Center, this year's El Niño has an 81% chance of joining that list, and a 63% chance of ranking among the strongest events ever recorded, in data that stretches back to 1950. Here's the exact timeline of how we got here. Through the winter of 2025 into early 2026, the Pacific was sitting in a weak La Niña, the cool phase of the cycle, gradually fading toward neutral conditions. By spring, subsurface ocean temperatures across the central and eastern Pacific had already begun climbing well above average, a classic early warning sign that forecasters watch closely. On June 11, 2026, NOAA officially declared El Niño had formed. Since then, it hasn't just continued strengthening, it's accelerated faster than most of the model forecasts predicted back in the spring. That acceleration is part of what has scientists on edge. Multiple international forecasting systems, including NOAA, the European Centre for Medium-Range Weather Forecasts, and Australia's Bureau of Meteorology, have converged on the same conclusion in recent updates. This event is now trending toward record-breaking intensity, with some forecasts suggesting it could rival or exceed the previous strongest events on record. But strength alone isn't the surprising part. Strong El Niños have happened before. What scientists didn't fully expect is what's happening underneath it. For more than a year before this El Niño even formed, a separate and unrelated marine heat wave had already taken hold off the California and Baja California coast. This wasn't triggered by the tropical Pacific dynamics that drive El Niño. It was driven by a different mechanism entirely, a persistent zone of high atmospheric pressure sitting over the eastern Pacific, the kind of calm, sunny, wind-suppressing weather pattern that lets ocean water sit still and simply absorb heat for months on end without the usual wind-driven mixing that would cool it back down. That heat wave has been active since May 2025, and as of the most recent assessments, waters off central and southern California have an 80 to 100% chance of remaining in marine heat wave conditions through the end of 2026. Under normal circumstances, El Niño and a pre-existing marine heat wave are treated by forecasters as separate phenomena with separate causes. What's raising alarm now is that instead of one system fading as the other strengthens, both are expected to persist and compound at the same time, layering tropical-driven warming directly on top of an already historically warm baseline. NOAA researchers have said plainly that while the two aren't directly caused by one another, their combined effects are expected to intensify each other's impact on the coast. This exact combination has a precedent, and it's not a reassuring one. From 2014 through 2016, a similar setup occurred when a persistent marine heatwave researchers nicknamed the Blob collided with the powerful 2015 to 2016 El Niño. The result was the largest marine heatwave ever recorded in the Northeast Pacific up to that point, and its ecological toll was staggering. Roughly 100,000 seabirds, mostly common Murrays, starved and washed ashore across the Pacific coast because the fish and forage species they depend on had moved or crashed in numbers. Sea lion pups on California's Channel Islands were found stranded and severely malnourished in record numbers because nursing mothers couldn't locate enough food nearby. Harmful algal blooms exploded across the coast, at one point shutting down the entire California Dungeness crab fishery due to dangerous neurotoxin levels found in the shellfish. Salmon runs collapsed in several river systems because warm water disrupted the cold water conditions juvenile fish need to survive migration. Scientists studying the current setup are explicit that this year's combination could rival or exceed that event, precisely because the marine heatwave component didn't need El Niño to get started. It was already running hot for over a year before El Niño arrived to add fuel to it. Here's what that looks like in exact numbers along the California coast right now. At Scripps Institution of Oceanography's monitoring station in La Jolla, water temperatures have been recorded up to 10 degrees Fahrenheit above the historical average during peak readings this year. Compare that to a typical year, where coastal water off Southern California sits around 68 degrees in late summer. If this event tracks with the two strongest previous Super El Niños, in 1997 to 1998 and 2015 to 2016, water temperatures at that same Scripps station could climb as high as 74 to 76 degrees by late summer, temperatures usually associated with subtropical, not Southern California, waters. Marine biologists are already documenting the early signs of that shift. Species that normally stay well south of the California coast, including squid, anchovies, and sardines, are being pushed north into unfamiliar waters, dragging predators along with them. Researchers at Long Beach State University's Shark Lab have specifically flagged an increase in sightings of hammerhead, tiger, and bull sharks off the California coast during past strong El Niño years, species that typically prefer far warmer water than California usually offers. Now here's the part of this story that matters most if you actually live in California. Because a Super El Niño doesn't just change what's happening in the ocean, it fundamentally reshapes what happens in the sky above the entire state for the following winter. During a strong El Niño winter, the jet stream over the northern Pacific typically shifts south, dragging the main storm track directly over the southern half of the United States, including Southern California, instead of its usual path further north. That shift is exactly what produced the two most destructive El Niño winters in modern California history. During 1982 to 1983, extreme rainfall triggered widespread flooding and mudslides across the state, and that same event caused such severe disruption to global weather patterns that some rivers in Peru were recorded carrying 1,000 times their normal flow. During 1997 to 1998, another historically powerful El Niño brought similarly destructive flooding, coastal erosion, and storm damage across California, one of the wettest and most damaging winters the state had experienced up to that point. Not every strong El Niño delivers the same result, and that inconsistency is part of why forecasters remain cautious, even as they raise alarms. The 2015 to 2016 Super El Niño, despite being one of the strongest ocean-based events on record, actually failed to deliver the expected flood of rain to Southern California that scientists anticipated. It still caused significant measurable damage, driving record beach erosion along large stretches of the California coastline, but the widely predicted Godzilla rainstorms mostly didn't materialize that particular winter. Climate scientists are quick to point out that no two El Niño events behave identically, and local outcomes on land can diverge meaningfully from what ocean temperature data alone would predict. Still, current forecasts for this winter lean heavily toward a repeat of the more destructive pattern rather than the milder 2015-16 outcome. Climate scientist Daniel Swain has specifically projected that this year's Super El Niño will produce a temporary sea level rise of approximately 6 inches along the California coast. That number doesn't exist in isolation. It stacks directly on top of long-term sea level rise, already caused by climate change, which Swain notes ranges from roughly 6 inches to a full foot over the past century, depending on the specific location along the California coastline. Combine a temporary 6-inch El Niño-driven surge with an already elevated baseline and coastal flooding during high tides and storm surges. This winter could reach levels well beyond what those communities have experienced in recent memory, even without accounting for the rainfall itself. There's a broader climate context here too, and it's part of why scientists are treating this specific event differently than past Super El Niños. Global average temperatures are already running more than 1.4 degrees Celsius above pre-industrial levels, a baseline no previous Super El Niño ever formed on top of. Researchers, including climate scientist Friederike Otto at Imperial College London, have been careful to note that El Niño itself isn't inherently alarming. It's a natural recurring cycle the planet has experienced for thousands of years. What's different now is that this natural warm phase is layering directly onto a climate system already pushed further than at any point in recorded history, and scientists genuinely don't have a complete precedent for how the two combine at this scale. Forecasters are already projecting that 2026 and potentially 2027, as the delayed effects of ocean heat continue radiating into the atmosphere, could rank among the hottest years ever recorded globally. There's also a wrinkle in how scientists even measure these events that's worth understanding, because it's part of what's made this year's forecasts more uncertain than usual. For decades, El Niño strength was measured almost entirely using something called the Oceanic Niño Index. The 1982 to 1983 event remains one of the most destructive El Niños in modern record-keeping. It arrived largely without the kind of early forecasting systems available today, catching both scientists and coastal communities off guard. Storms battered the California coast that winter with such force that entire piers were destroyed, cliffside. Homes collapsed into the ocean, and statewide damage estimates climbed into the billions of dollars once inflation is accounted for. Globally, the disruption was severe enough to alter rainfall patterns as far away as South America and Australia, with some Peruvian rivers recorded carrying roughly 1,000 times their normal flow. The 1997 to 1998 event, sometimes nicknamed the Godzilla El Niño by forecasters at the time, was in some ways even stronger by raw ocean temperature measurements. California endured a brutally wet winter with widespread flooding, mudslides, and coastal erosion across the state. Climatologists at the time described sea surface warming and wind pattern shifts stronger than anything measured up to that point, and the storms that followed lined up almost exactly with worst-case forecasts. There's another layer to this that specifically affects California's water supply and drought recovery. After several consecutive dry years earlier in the decade, California's reservoir levels and snowpack recovery have remained a persistent concern for water managers across the state. A wetter-than-average El Niño winter, if it materializes the way 1982-83 and 1997-98 did, could meaningfully replenish reservoirs and mountain snowpack heading into 2027, offering real drought relief even as it brings flood risk. Water agencies across the state are already adjusting reservoir release schedules and flood control planning, specifically in anticipation of a wetter winter, trying to strike a balance between capturing badly needed water and avoiding dangerous overcapacity heading into storm season. Wildfire risk carries its own complicated relationship with El Niño as well. A wetter winter typically means more vegetation growth across California's hillsides and grasslands come spring, which can initially suppress fire risk by keeping the landscape greener longer into the following summer. But that same vegetation growth becomes fuel once it dries out later in the year, and burn-scarred hillsides left behind by recent wildfire seasons face a heightened risk of dangerous mudslides and debris flows if this winter's storms hit as hard as 1997-98 did, since burned ground loses much of its ability to absorb heavy rainfall. There's also a hurricane season angle worth understanding, since El Niño's influence extends well beyond California's coastline. Strong El Niño events typically suppress Atlantic hurricane activity by increasing wind shear across the basin, which disrupts storm formation. Forecasters at Colorado State University specifically cited this year's strengthening El Niño as a key reason for predicting a below-average 2026 Atlantic hurricane season. At the same time, El Niño tends to have the opposite effect in the Pacific, often supporting more active hurricane development off Mexico's Pacific coast and in the Central Pacific near Hawaii, another region closely tied to the same warm ocean conditions currently building off California. For California residents specifically trying to prepare for what's ahead, several concrete steps line up directly with what forecasters are watching for. Coastal property owners in flood-prone or erosion-prone areas are being encouraged by local emergency management agencies to review flood insurance coverage before storm season begins, since standard homeowners insurance typically doesn't cover flood damage. Residents near recent wildfire burn scars are facing renewed mudslide and debris flow warnings, with several counties already updating evacuation planning specifically for this winter. Anglers and coastal recreation groups are being advised to expect further disruption to typical fishing patterns as warm water species continue shifting north into unfamiliar waters. And statewide water agencies are asking residents to prepare for a winter that could swing between welcome drought relief and dangerous flood risk within the same storm season, sometimes within the same week. California's agricultural sector, which produces a significant share of the country's fruits, vegetables, and nuts, faces its own distinct set of risks tied to this event. Excess rainfall during critical growing and harvest windows can damage crops, delay planting, and saturate fields to the point where heavy equipment simply can't operate. At the same time, the same rainfall that threatens short-term crop damage could help replenish groundwater aquifers that farmers across the Central Valley have relied on heavily during recent drought years, often pumping faster than natural recharge could keep up with. Agricultural water districts are watching this winter's outcome closely, aware that either extreme, A repeat of the destructive 1997-98 flooding, or a repeat of 2015-16's underwhelming rainfall, carries real consequences for the state's farming economy. Kelp forests along the California coast, already stressed by warm water events over the past decade, represent another closely watched indicator. Researchers at the Monterey Bay Aquarium have been tracking kelp recovery efforts in Monterey Bay, noting that warmer water conditions this year have already been detectable during routine dives, even before El Niño's full seasonal effects arrive. Kelp forests are foundational to the broader coastal ecosystem, providing habitat for countless fish and invertebrate species, and prolonged warm water stress can trigger die-offs that take years to recover from, as seen in parts of Northern California following the 2014-2016 heat wave event, where large stretches of kelp forest collapsed and were replaced by urchin barrens that persisted for years afterward. Breaking this down by region gives a clearer picture of what different parts of the state are actually bracing for. Southern California, historically the region most sensitive to El Niño's storm track shift, faces the highest probability of significantly above average rainfall if this event follows the pattern set by 1982-83 and 1997-98, along with corresponding risks of flooding, coastal erosion, and mudslides in burn-scarred hillside communities across Los Angeles, Orange, San Diego, and Riverside counties. Central California, including the Bay Area, typically experiences a smaller but still meaningful increase in precipitation during strong El Niño years, with coastal erosion and high tide flooding, as the more immediate concerns given the region's extensive shoreline infrastructure and low-lying area, as around San Francisco Bay. Northern California generally sees the least dramatic shift in rainfall patterns during El Niño winters compared to the southern part of the state, though marine ecosystem impacts along the northern coast, including disruption to salmon runs and increased algal bloom risk, remain a serious concern independent of how much rain actually falls there. Emergency planners across the state have been explicit that the uncertainty in this year's forecast doesn't reduce the need for preparation, it increases it. Because the atmospheric response remains genuinely unpredictable, even with historically strong ocean warming as a baseline, agencies are essentially preparing for the more severe scenario while hoping for the milder one. That approach specifically means pre-positioning flood control resources, clearing storm drains and debris basins ahead of the winter season, and issuing early public messaging about flood insurance and evacuation planning well before any specific storm system is even on the radar. It's worth stepping back one more time to appreciate just how unusual the underlying setup really is. Marine heat waves and El Niño events aren't new phenomena individually. Both have occurred repeatedly throughout the historical record, and scientists understand each one reasonably well in isolation. What's genuinely new is watching a marine heat wave persist for over a year, entirely independent of El Niño, and then have one of the strongest El Niños in the historical record arrive directly on top of it while global temperatures are already running higher than at any point in recorded history. Researchers studying this exact kind of compound event, an already warm ocean colliding with a strong El Niño, have found in past cases that the interaction doesn't behave like simple addition, sometimes producing effects more extreme than IDR system would create on its own. That's precisely the dynamic scientists are now watching unfold off California in real time, and it's a large part of why this year's event is being treated differently than previous super El Niños, even ones that reached comparable ocean temperatures. There's also a satellite and monitoring story here worth understanding, because it explains how scientists are able to track a compound event like this in real time at all, something that simply wasn't possible during earlier super El Niños. NASA's Sentinel-6, Michael Freelich satellite, launched specifically to monitor sea surface height with extraordinary precision, has been tracking the Pacific's rise in near real time throughout 2026, giving researchers a far more detailed picture of exactly how much warm water is piling up and where it's headed than was available during the 1997-98 or even the 2015-16 events. That improved monitoring is part of why forecasters have been able to flag this compound marine heat wave and El Niño interaction so early, rather than only recognizing the pattern after the fact, the way scientists largely had to during the 2014-2016 blob event. None of that improved monitoring changes the underlying uncertainty about exactly how strong the atmospheric response will be once winter arrives, but it does mean California and the scientists studying it are going into this event with better data and more advanced warning than during any previous Super L. Niño in the historical record. Whether that translates into meaningfully better outcomes for coastal communities, fisheries, and inland flood zones will become clear only as the winter unfolds, and the specific storm systems either do or don't line up with the more destructive precedents this event is currently tracking toward. For now, the exact numbers to watch heading into fall and winter are these: an 81% chance of crossing the 2 degrees Celsius super El Niño threshold, a 63% chance of ranking among the strongest events since 1950, An 80 to 100% chance the existing marine heat wave persists off California through year's end, and a projected 6 inches of temporary sea level rise stacking on top of already elevated coastal water levels. Every one of those figures will keep updating as new data comes in, but together they represent the clearest picture available right now of a winter that could look very different from an ordinary year, one way or another, along nearly the entire California coastline.